Hello. So the question was about this, I think it was from the other old sample test, but it's still a good question, about trying to solve a quadratic like this when you've got particularly both the exponents and the fractions. Now the first thing you generally want to do with a problem like this is get rid of those fractions. You could plug it into the quadratic formula with an a equals 1/3, a b equals 1, and a c equals 2/5, but that just starts to make a horrible, horrible mess. Completing the square would cause the same kind of issues, the same kind of mess. Actually, precisely the same mess. So getting rid of those fractions, getting them out of our way first is really going to be handy. And we can do that by recalling our method of clearing fractions. If we multiply that by 15 on both sides, 15 being the common multiple between 5 and 3, kind of like a common denominator, we're going to end up with 15 times each of those pieces. And the nice thing about 15 is the 3 will divide into the 15 cleanly, and the 5 and the 2/5 will divide into the 15 clearly. And 15 times 0 is, of course, still 0. Don't let that become 15 on you. So those will divide clean, leaving a 5x squared plus 15x. We do need to multiply the 15 by the x, even though it doesn't help us. Kind of the consequence we pay. 5 goes into the 15 3 times. So 3 times 2, that's just going to become a 6. Now we just have a quadratic. It's got a lead coefficient, but that's okay. So we want to factor this if we can. Let's see, 5 times 6 is 30, multiplies to 30 and adds to 15. Nothing occurs to me nicely, so if it's not something that we can factor or factor nicely, we can either complete the square or use the quadratic formula, but of course the quadratic formula is derived from completing the square. So generally we factor, if possible, quadratic formula if not. So if we want a quadratic, a equals 5, b equals 15, c equals 6. Remember, to do this we have to be set equal to 0, but we are, so we're okay. I like to find the discriminant first. The discriminant, as you may recall, b squared minus 4ac. That's the part under that radical. So 15 squared is, what, 225 minus 4 times 5 times 6. Sorry, a little messy. So 225 minus, what is that, 4 times 30? It's 120. So 105. So the discriminant being 105, it's positive, so we'll end up with two answers. It is not a perfect square, so we know it indeed wasn't factorable, so that's nice. So we didn't miss anything. So we can go from here directly to the full quadratic formula. Remember, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac, so we already found that, that's our d, over 2a equals our x. That does say x equals. So we really didn't waste any time doing this 105. We still need the negative of b, so negative 15 plus or minus the square root of our discriminant, 105, over 2 times 5 is 10. The 105, square root over 105, won't clean up. That is, what is that, 25 times... brain hurts. 21 times 5, and 21 times 5 is 3 times 7 times 5. There's no perfect squares in there, so it's not going to simplify. Be careful about trying to divide a 5 out of both of those. That 5 has to go into every term, so, I mean, you could, if you really, really wanted to, write this as negative 15 over 10 plus or minus square root of 105 over 10. And then get negative 3/2 plus or minus the square root of 105 over 10. But I'd really have a hard time arguing that that's better than this. So likely we're going to just stop there. So those are your two solutions, one for the plus, one for the minus. And really this problem comes down to clearing the fractions to make it into a nicer quadratic. Once it's this nicer quadratic, our general quadratic skills take over, which means factor if possible, quadratic formula if not. I hope that helped. Let me know.